Hello everyone, welcome to the fourth section of the tutorial 0. I promise this will be the last section, no tutorial 0 anymore. So in this tutorial, I will talk about some advanced STEM syntax and STEM concept. So this video is actually optional. I guess some of you have noticed that in the regression example above, there are some strange things. So first, you may feel weird that why we have y tilde normal but we also have prediction y equal to normal RNG. And the second weird thing is that why we have vector n y, but we also have real prediction y n. And the third weird thing is that why we need to declare mu in both the model part and the generated quantities block. However, we don't need to declare alpha, beta, or gamma. In this video, I will answer the above three questions. Firstly, I will answer the tilde normal versus normal RNG. So the tilde sign can only be shown in the model block. And the syntax tilde with any distribution will be a sampling statement. What is a sampling statement? So basically, sampling statement will tell Stan that this line should be included into the calculation of likelihood. Stan will find the mu and sigma that can maximize this likelihood function. In the future classes, we will have not only tilde normal, but we will have tilde binomial, tilde Poisson, or tilde multinormal functions. On the other hand, the normal RNG function, well, it's just basically the R norm function in R. So it's a generative function. It will draw a random sample from the normal distribution with the mu and sigma. I mean, these two values are defined value. And next, we will talk about a vector versus a real. So this vector n, y, will be a vector of length n, and a vector will support a linear algebra calculation in. On the other hand, real predict y n is an array of real values and with length n. So the real array will not support linear algebra calculation, but it can also store a lot of real numbers. So what are the linear algebra calculation? So for example, if we set x and y to vectors, and we can calculate the mu value by just one line. Or if we set x and y to real array, we have to use a for loop like this to calculate the mu value one by one. So there are some disadvantages for vector as well. So like in the generated quantities block, we will use a normal RNG function, and normal RNG function doesn't support a vector. The output will be an array of reals. So if we want to do normal RNG in one line without the for loop, the prediction y must be set as a real array. Alternatively, of course, you can declare the prediction y be a vector, and you can use the for loop to do the same thing. And you can see that now you are calculate the result one by one. The question is that why we need to declare mu again in the generated quantities block. So Stan have the variables in Stan have different scope in each block. Variables declared in the model block are local variables and can't be used directly in other blocks. But the data and parameters or transform data and transform parameters are global variables. So we don't need to declare alpha, beta, gamma, things like that again. So if you don't want to declare mu for twice, and you can actually declare mu in the transform parameters block. If you declare mu in the transform parameters block, it can be directly accessed in the model block and the generated quantities block. This is the end of tutorial 0.4. I hope this video can help you reduce the time on debugging the STEM model.